Hello. As I teach courses in fluid mechanics at the university and also do research in this area, the importance of visualizing the flow, the visualization of the data representing turbulence flow becomes very important. It's a separate issue from acquiring that data, so making measurements, either optical or otherwise. This summer, particularly, I was attending a keynote presentation by Professor Cumpsty from Imperial College at the summer school for advanced research in turbomachinery. And Professor Cumpsty was talking about history of research in jet engines, compressors, and so forth, and the research of turbulence as it relates to that engineering application. And turbulent flows are 3D and unsteady, so they are both three-dimensional and time-dependent. And he pointed out that the important thing that's often overlooked, actually at all levels of researchers, is that turbulent flows are not constant, average, small perturbations of velocity. They are characterized by occasional large perturbations, and this has been pointed out by Osborne Reynolds himself in 1885. So this instantaneous three-dimensional nature of turbulent flows is very important, and visualizing and understanding this conceptually is important. So we can obtain that three-dimensional information either numerically by doing CFD or experimentally by doing particle image velocimetry, even tomographical PIV. So the data is there, but transferring that information, converting it to knowledge is an elusive thing. So you need to visualize it, and we can make 3D plots, of course, so at the various instances in time, but those are projected on a 2D plane. So that is really limiting in terms of offering physical insight. So what I've been playing with is trying to come up with a pipeline or workflow for flow visualization using augmented reality. So this is an example of what we've been looking on in turbomachinery area. So this is the flow in the wake of a H-Darrieus turbine. It's a vertical axis tidal energy device. And so I can bring up a 3D plot representing the flow in the wake of a device to a VR headset and put it virtually on my desk here. So that allows me to interact with data, so I can turn it around, observe it from various directions. But that is part of the deal. So what we're looking at here is the representation of vorticity in the wake of a rotor. So this is an interesting flow representation. It's a collection of two-dimensional data with time represented by another direction. So if I take this plot, and in this direction along this axis is time, so a contour of vorticity, which is a measure of amount of rotation in the flow at a given point in space, at each cross section in this plane there would be a contour of vorticity as it's being shed from the blades of a rotor, which is located here. So in each plane in this direction, there is a vorticity that's shed from the blades at a particular phase of the rotor. So it's at an instant in time corresponding to a certain position of the rotor. And as the time progresses in that direction, that vorticity is convected in the flow, and we can look into how the vortices that are shed from the certain blade at a particular instant in time, as the time progresses, they interact with vortices that are shed subsequently at different instances in time. So that is very useful. So this type of flow visualization, this way of looking at flow data, is useful both for teaching purposes. You can observe various phenomena such as vortex shading, transition to turbulence, etc., dissipation of vorticity in the wake with the downstream distance, for example. So here the flow direction is from right to left, and you can see that the vorticity levels diminish both in the streamwise direction and in time as the rotor moves and the vorticity is convected. So this type of insight is useful educationally, but also for research purposes. And I think flow visualization itself is it's a worthwhile subject to pursue because it offers potentially new insights into the flow physics. So please consider it if you have a chance, and hopefully we will have some exciting new information available to us through this new technology.